All right, I want to invite the next speaker, who's Anjana, who's going to speak about testing. Anjana, stage is yours.
Thank you, Tofi. Am I visible? Yeah. Hi everyone, I am Anjana. I am a QA trainee at the Archi Academy. I have been learning manual testing for some time, and today I am going to present about software testing techniques. Today, my agenda is, first of all, I am going to give an introduction about software testing, why we are using software testing. Next, I am going to deep into the classifications of the software testing techniques and also discuss about some of the important software testing techniques being used and also concluding with points. First of all, what is software testing? You all know software testing. Software testing is a part of the software development process. It's an activity to detect and identify errors in the software. It is a method to check whether the expected software is meeting the criteria or requirement criteria or not. That is, software testing is used to evaluate and verify that a software product or application that does what it's supposed to do. Also, software testing ensures software product is defect-free or not. Software testing can be done in two ways, manual testing and automation testing. In manual testing, we are testing the software by hand. That means we are manually testing. That is, the tester need to act as an end user and he need to test each and every functionality of the application. Whereas in the automation testing, the tester need to use some automation tools and he need to write some code for it and it automatically finds the errors in the program. Next, why we are using software testing. Software testing is very important because it discovers defects or bugs before the delivery of the product to the customer so that we can deliver high quality product to the customer. Also, software testing makes software more reliable and easy to use. Thereby, we can save time and also cost. Also, thoroughly tested software ensures reliable and high performance software operations. Basically, software testing techniques can be divided into static testing technique and dynamic testing technique. Static testing technique is a technique which is used to check the defects or errors in a software without executing the code. That is, it is done to find out the errors without executing the code, and it is done at the early stage of the development. Here we are checking the documents and files. Static testing technique is done in 3 weeks: reviews, walkthrough, and inspection. In the case of reviews, we need to read the document first and that we need to check whether all the contents are written or not, or whether it is completely written or not, and also check whether if the written contents, whatever are the written contents, we need to check all these are correct or not. We need to check all these factors. And also the important thing is that it is done, can be done by anyone at any time. And in the case of walkthrough, it is also based on the documentation and it is the informal type of review. And here the author needs to read the document and he needs to discuss it with his peer members. Next is the inspection. Inspection is the most formal type of review, and here it consists of a group of 3 to 8 people, and in which they are divided into 3 groups: reader, writer, and moderator. Reader is a person who is the author of the document, and writer is a person who writes down all the points and issues, whatever is raised in the meeting, he writes down all those points. And also moderator is the person who organizes the meeting. And one important thing is that it has a proper schedule and it should be informed to the concerned developer or tester by email. Next is the dynamic testing. Dynamic testing is used to test the dynamic behavior of the software. Here, the code is being executed in order to find the dynamic behavior of the software. In dynamic testing, we are performing using the application. That is, we are actually executing the code and seeing if the functionality works the way it is expected or not. Dynamic testing technique can be performed in 3 ways: structure-based, classification-based, and experience-based. First one is the specification-based technique. Specification-based technique is also called black box test. Here, it is a method of testing in which the internal structure or the design or the code is not known to the tester. That is, the tester has not need to study any programming, or he does not need any programming language skills. It involves testing either functional or non-functional features without reference to the internal structure of the system. Some of the important techniques that is included in the specification-based technique is equivalence partitioning, boundary value analysis, decision tables, state transition, and use case testing. Next is the structure-based technique. Structure-based technique is also called white box testing. Here, the internal structure or the design or the code of the application or the system should be known to the tester. That is, the tester should have knowledge of programming, and here we need to check the system is performing based on the code or not. And it is again classified into statement, decision, condition, and multiple condition. Next is the experience-based technique. Experience-based technique is based on the skill and experience of the tester. Here, the tester depends on his past experience with similar applications or technologies, and he needs to use those experience with similar applications in the present condition. So, this technique purely depends upon the skill and experience of the tester. And the techniques included in the experience-based is error guessing, exploratory testing. Next, I am going to discuss more about some of the commonly used testing techniques. First one is the boundary value analysis. Boundary value analysis actually is a specification-based technique, that is a black box testing. Here we are testing between extreme ends or boundaries between the partitions of the input. That is, basically we are testing small chunk of data from a bulk data. That is, we are testing only 6 values. Minimum minus 1, minimum plus 1, maximum minus 1, maximum plus 1. For example, a textbooks have entered an age from 18 to 35. We need to check. From 18, we doesn't need to check each value 18, 19, 20, like no. We only need to select the 6 values so that testing becomes more easier. That is, we need to select 18 minus 1, that is 17, 18, 18 plus 1, 19, 35 minus 1, that is 34, 35, and 35 plus 1, 36. Here we can see that 2 values become invalid. That is, 17 and 36 become invalid. That is, if we test it, the test will fail. In this way, we will perform the boundary value analysis. Next one is the equivalence partition. In the equivalence partition, we will divide the entire set of data into certain equivalent classes, and we will select one particular element from each class and test that. That particular element will represent all the elements in the equivalent class. For example, a text box takes values 1 to 500. Here we are dividing the entire data into 7 classes, minus 100 to 0, 1 to 100, likewise 501 to 600. From each class, we are taking one single value and test. That is, from minus 100 to 0, we are taking one single value and test. So, in order to check from values ranging from 1 to 500, that lots of numbers are being checking if we are actually doing testing. But instead of that, we need to test only some chunks of values from that. And also, Also, we need to, we can identify that whatever is passing, whatever is failing in this. Next is the decision table testing. Decision table testing, which is used for functions which respond to a combination of inputs or events. Also, it is called cause-effect table. First task is to identify the functionalities in which the output depends upon a combinations of inputs. Then we need to create a table and list down all those inputs to their corresponding outputs. Let us, for an example, we need to transfer money online to an account which is already added and approved. We have certain conditions for money transfer. That is, the account is already approved, OTP should be matched, sufficient money in the account. And the actions to be performed are money can be transferred. We should show a message if there is an insufficient balance in the account, and also block the transactions in case of suspicious action is going to occur. In the table, we need to first write the conditions first in the first column, and after that we need to write the actions. In the top row, we need to write the test cases. In the first, as the first test case, we are considering all the conditions are true. That is, the account is already approved, OTP is matching, and there is sufficient money in the account. By satisfying all these conditions, we can transfer the money. So that action is performed. In the second test case, account is already approved, OTP is matching, but not sufficient money in the account. Then we can say that the action, that is, we have to show a message that there is insufficient money in the account. That action is performed. In the next test case, TC3, account already approved, OTP is not matched, and also there is not sufficient money in the account. Since OTP is not matching, we can have a guess that there's any suspicious action is going to occur. So we need to block that transaction. So that action is performed. In TC4, account is already approved and OTP is not matching, and there is sufficient money in the account. Since OTP is not matching, we have to block the transaction. That action is performed. In TC5, the account is not being approved, so we cannot do any action in this. In this way, we are performing the decision table testing. Next is the state transition diagram. State transition diagram, the changes in input conditions change the state of application under test. Here, the tester analyzes the behavior of an application under test for different inputs. And the testing team also provides positive as well as negative input values for evaluating the behavior of the system. For example, the login page of an application which logs the user name after the third wrong attempt of password. That is, for example, here a person who tries to log into his account with correct password, he can access his account. If he has wrong password, he has given another chance. In the second chance, if he given correct password, he can access his account. If he is given wrong password, he is given a third chance. In the third chance, if he gives the correct password, he can access his account. But if he fails to provide the correct password in the third attempt, his account is blocked. Let's look how we can draw a transition diagram using the table using this. That is, here there are certain states there. That is, start is the first stage, first attempt is the second S2 state, and second attempt is S3 state, third attempt is state S4, fifth attempt, access granted is the fifth state, account blocked is the state S6. In the first attempt, if we are giving the correct password, access granted state, that is state S5 is obtained. If he is given incorrect password, he has given a next track, that is the state S3, that is the second attempt. In the second attempt, if he is giving correct password, he can access his account, that is state S5 is obtained. If he is giving wrong password, the state he has given a third chance, that is state S4 is obtained. And in the third attempt, If he is giving correct password, access granted state is there, that is state S5. If he is giving wrong password, then his account is blocked. That state is state S6. In this way, we will form the state transition table. Next is the error guessing. Error guessing technique is guessing the error which can prevail inside the code. Here, the test analysts use their experiences to guess the defect part of the application, and the test analyst uses his skill and experience to guess the error. Here, this is done used during the release of the application, and there should be certain guidelines for error guessing for the testers. The testers should use the previous experience of testing applications, and also he should understand thoroughly the system under test, and he should have the knowledge of typical implementation errors, and he should remember previous trouble areas, and also he should evaluate historical data and test results. Now let me summarize the main points. That is, software testing techniques allow us to design better test case. Each technique will be good in its own way. We cannot say one technique is good and one technique is bad. Depending upon the kinds of defects, we need to select the software testing techniques. One technique should be good for one kind of errors, but it should not be good for other kinds of errors. And we need to select the software testing techniques depending upon the kinds of the errors. That's all. Thank you for being here today, and really appreciate your valuable presence for my presentation.